In this lecture, we are going to cover the player's jump and the jump animations. Let's go to the player blueprint. If you search jump, you are going to get the input event. This is the event that is going to be called by the jump input action, which we created in the previous lecture. Let's drag out from press. This is going to be triggered when the key for the jump action is pressed. Then we just search for the jump action. It's under the character class. Like I mentioned, the character class provides us with most of the functions that we need for the player's movement. You can also hover your mouse cursor over it to see the detailed information. Let me compile the blueprint, then test the game. Alright, it works. Let's ignore the mismatched animations for now and just focus on the jump movement. I feel like the jump is way too high, and we don't have much air control, meaning we cannot change the player's direction when it's airborne. Let's stop the test and go back to the player blueprint. Select the character movement component to do some tweaks. Let's scroll down until we find character movement jumping/falling. Let's try to decrease the jump Z velocity to 350. Then for air control, I'm going to increase it to 0.6. Alright, let's compile and test. Now it feels much better. I can also change direction while I'm jumping. I think you should spend more time testing different values until you find the perfect numbers for your game. Next, let's handle the jump animations. First, let's create two flipbooks. Go to the player folder. I'm going to create two new folders here. I'm going to call the first one player jump up. I'll make another folder and call it player jump down. Open the player jump file. This sheet contains the frames for both the jump up motion and the jump down motion. We are going to extract all of the frames, but make them into two flipbooks. Let's right-click on player jump, sprite actions, then select extract sprites. Change the method to grade. The cell width is 64. Alright, then just hit extract. I'm going to reselect the first 7 sprites and move them to the player jump up folder. Then for the last 3 sprites, we move them to the player jump down folder. Go to the jump up folder, select all the sprites here, right-click create flipbook. Rename the flipbook to player jump up. Then go to the jump down folder, also select all of the sprites, create a flipbook, and rename it to player jump down. Alright, now we have the flipbooks we need. Let's save the new files. Go back to the player blueprint. Then let's go into this update flipbook node. Here's where we update the input and walk animations. We need more space here, so let's move the inputs node and disconnect the setFlipbook function. Also select all of these nodes. Hit the C key to add some comment. I'm just going to call this update idle and walk animations. This comment is going to help us understand what these nodes are doing here. Let me move the outputs node outside of the comment. The first thing to do here is to check if the player is jumping. We can reuse these nodes to get the z velocity of the player. Be aware that we are using the z velocity, which represents the vertical movement. Then let's check if its value is 0. Then we can use an if node to branch the flow. Connect the inputs with the branch node. When the branch is false, which means the player is not jumping, we want to update the idle or walk animations. So let's connect false to the setFlipbook node that we created before. Then we update the jump animations when the branch is true. We need to know if the player is jumping up or falling down. So let's check the z velocity again. This time we want to check if it's greater than 0. Then we create another branch here. So we can decide if we want to play the jump up animation or the jump down animation based on the Z velocity. This connection is a bit messy. We can double click on the line to create a reroute node. Alright, next we can reuse the setFlipBook node below. Let's just copy it and paste it back up. Don't forget to copy the sprite altogether, since it's the target of the function. Then for the true condition, which means the player is jumping up, select the player jump up animation. Then let's paste the nodes again. And this is for the false condition. We select the player jump down animation, since the player is falling down in this case. We can clean up this a little bit, since we can connect one sprite to two functions, and this should be enough. Alright, let me zoom out so you can see the full graph. Then we can compile and test the game. Now you should see the jump animations playing when the player is airborne. But the animation is jiggling, especially when the player is falling down. This is because the up and down animations are looping, and they're not supposed to do that. The animations should just stop and hold the last frame when they are finished playing. It's actually very easy to set the looping of the animations. But before that, let's just comment out the nodes we just added. I'm gonna select these ones. Press the C key to comment. I'm just gonna say what we're doing here is updating the jump animations. Alright, let's handle the looping. We only want the animations to stop looping when the player is jumping, because for the idle and walk animations, we still need them to loop. Let me drag out the sprite component and call the setLooping function on it. Let's make this happen before the first branch. So we set the looping first, then we decide which animation to play. And we can again reuse the Z velocity. We can reuse the node where we check if the Z velocity equals 0. Let's move these nodes to the right. And we want to reverse the result of this node. Let's use the not Boolean node. This function reverses the input Boolean value. So when the player is jumping, we are going to get a false value from this node. Conversely, it's going to be true when the player is on the ground. We connected it to the setLooping function. Alright, let's run the game to check. The idle animation is looping, and the jump animation should not be looping. But now we have a new problem. All of the animations are not going to play after we jump. I think this is because when we set the animations to not looping, it somehow stops the animations to autoplay. So if this is the case, then we need to force the animation to play again after setting looping. I'm just going to call the play function on the sprite, and this has to happen after the setLooping function. Then we connect it to the branch and test the game. Alright, now the animations are looking pretty good. I'll just move around here a little bit more to check if everything works very well. Alright, let's come back to comment out the nodes we just created. I'm gonna move these aside so we have more space here. Then I want to reroute the line from the sprite node to the play node. Double click to create a reroute node. Alright, I think this looks better. Then let's select these nodes and comment out. I'm gonna say these are to set the looping. Then let's rearrange other nodes to make the graph look tidy and organized. Alright, this is the full graph for now. As you can see, it's already quite complicated, and we are only managing a few animations here. It's very hard to imagine how we can manage all of the animations in this way. This is why I mentioned before that this is probably not the best way to manage the animations. But nevertheless, I would say This is a very basic way, and you do need to understand how to do this, so you have the idea of how the blueprint works. But all in all, this is just a demo of how to use Blueprint to control the Flipbooks. Very soon, we are going to discard all of this. I use a free plugin called PaperZD to manage the animations of the characters. And I'm going to show you the benefit of using PaperZD to do this. But before that, in the next lecture, let's add some jumping and landing VFX to the player.